Hello and welcome to InvaderBethany's laboratory! Yay! If you are one of my normal subscribers, this video is going to look a lot different than most of my other videos. That is because this video is for my physics class, and I'm going to get graded on it, so yeah. Hope I get a good grade. And without delay, let us begin. Today we're going to talk about the 5 phases of matter. Those include solid, liquid, gas, plasma, and Bose-Einstein concentrates. Let's start with solid. The particles in solid have very low kinetic energy. They're very tightly packed together, so it makes it hard to move about. The only moving they can do is small vibrations of the particles. In solids, they have definite shape and definite volume, and they are 3D objects. Some examples of a solid would be a pumpkin, a DVD, or perhaps a box that the DVD is in. This here DVD right here is Creepy Crawl's The Crawl Space. And I so happen to be in this, as you can see right here. Alright, next let's go to liquids. Liquids have more kinetic energy than a solid. The liquid particles are not held together in a regular shape, as you can see when it sloshes around. But the particles are still close enough to the liquid that it has a defined shape. Liquid changes shape to conform to its container, in case you didn't know that already. Liquids can move in vibration, rotation, and it also has a limited translation. Thirdly is gas. Gas has high kinetic energy. If not contained, the particles of mass will spread out indefinitely. Gas has no exact volume or shape. And because it is so freely moving, it can move in vibration, rotation, and translation. Now on to plasma. Plasma is not a common state of matter on Earth, but it may be the most common state of matter in the universe. It consists of highly charged particles with extremely high kinetic energy. A good example of plasma would be stars, since they are basically superheated balls of plasma. Another example would be glowing neon signs. They use noble gases like helium, neon, argon, xenon, and radon to make the signs glow by using electricity to ionize them to a plasma matter state. And lastly, we got Bose-Einstein concentrates. In the year 1995, scientists Eric Cornell and Carl Wyman created a new substance of matter by cooling a sample of rubidium to within a few degrees of absolute zero. At this extremely low temperature, molecule motion is so slow that it almost halts altogether. Since almost no kinetic energy is being transferred, the atoms begin to clump together, making thousands of atoms form together to become one superatom. Bose-Einstein concentrates have very odd properties. Light appears to slow down as it passes through Bose-Einstein concentrates, and superfluid, which is basically flowing without friction. These Bose-Einstein concentrates have been useful, though, in the study of quantum mechanics on a macroscopic level, and the study of particle wave paradox. Now that you know the 5 stages of matter, you might be wondering how to change the phases. Am I right? Well, melting is a solid to liquid change. When heat is applied to a solid, the particles vibrate faster and move apart. When the substance reaches a certain point of temperature, the solid will begin to turn into a liquid. This point is called the melting point, and it varies between solids. Freezing is a liquid to solid transformation. This happens when the temperature of a liquid is cooled down a lot. As the liquid cools, the particles move slower, which makes it solid. If the solid is converted directly to a gas, the kinetic energy of the particles are greater than the atmosphere pressure surrounding the sample. This change is called sublimation. This happens when a sample is exposed to a temperature that has rapidly increased beyond the boiling point, which is known as flash vaporization. Another way is by freeze drying. During freeze drying, a sample is cooled under the vacuum conditions so that the water in the substance undergoes sublimation and is moved from the sample. Vaporization is when a liquid becomes a gas. Liquid is in a constant state of motion and collides with particles, and this transfers energy. If enough energy is transferred from the particle near the surface, it will gain enough energy to knock away completely from the sample and become a free gas particle. This process is called evaporation and is one of the ways vaporization commonly occurs. The other way is by boiling. When heat is added to a liquid, vapor will bubble from below the surface of the liquid. The boiling point is dependent on the pressure the substance is in. And lastly, there is condensation. This is a phase in which a gas transforms into a liquid. This occurs when gas is cooled to the point where kinetic energy in the particles can no longer overcome intermolecular forces. If gas happens to skip condensation and directly become a solid, it is known as decomposition. A good example of this would be when water vapor becomes frost on blades of grass. And that's all I got. I hope you learned something today. Bye!